For the first time in history, humanity has seen this happen with its own eyes. Two galaxies colliding. The image was captured just 2 days ago. The James Webb Space Telescope recorded the moment when two distant galaxies crashed into each other. With a force so immense it could wipe out billions of solar systems, scientists called the image a milestone in modern visual astronomy. But the truth is, this isn't rare. In fact, it's already happening to our own galaxy, the Saturn. Milky Way has been fighting a silent war for billions of years. It consumes smaller galaxies, distorts entire cosmic structures, and it's headed straight for a final showdown with Andromeda. And the scariest part? Earth will be there when it happens. When two galaxies collide, what happens isn't what most people imagine. The first surprising fact is this: stars almost never crash into each other. Even in a massive impact, they just pass right by. Why? Because the space between them is insanely vast. So vast that even when entire galaxies collide, the stars still float through untouched, like two clouds merging in slow motion. But that doesn't mean the collision is harmless. Far from it. The spiral arms of the galaxies twist, stretch, and break apart. Bridges of gas form, tails of dust, currents of stars being pulled like cosmic threads unraveling in the dark. The interstellar gas, the same gas that gives birth to stars, smashes together head-on, triggering explosions of star formation that light up entire regions of space. These bursts, known as starbursts, create hundreds of new stars at once. The process is chaotic, fast, violent, like watching a stellar nursery being born in the middle of a cosmic battlefield. And while new stars are forming, something far more terrifying is happening deep inside each galaxy. The supermassive black holes are getting closer. They don't crash right away. They spiral around each other, pulling in everything nearby, warping space, flinging matter at insane speeds. Until one day, they merge. And when they do, they unleash a gravitational wave so powerful it ripples across the universe. When it's over, what remains is no longer what once was. The original galaxies are gone. What's left is a brand new galaxy, deformed, larger, with a new core, new stars, and a history written in destruction. And this is exactly what's about to happen to the Milky Way. The collision between the Milky Way and Andromeda isn't an event far off in some distant future. It has already begun, even if we can't see it. These two cosmic giants are moving toward each other at an impressive speed, about 110 kilometers per second. It sounds fast, but in space, it's a nearly silent advance, a motion that will last billions of years. Meanwhile, the space between the galaxies is filled with small satellite galaxies, cosmic dust, and clouds of gas. All these smaller bodies and particles will be affected. Some will be immediately swallowed by the growing gravitational pull, while others will be thrown into chaotic orbits, creating a real festival of destruction. But what will happen to our solar system? Will Earth be swallowed or thrown out into interstellar space? The answer isn't simple because it depends on one crucial detail: the position of our solar system within the Milky Way at the exact moment of collision. The solar system is located in one of the galaxy's spiral arms, about 27,000 light-years from the center. This means that when the galaxies begin to merge, we could be dragged into regions of intense activity, with stars being born and dying in supernova explosions. Or we might be ejected into quieter areas, with less radiation and colder temperatures. Simulations show that the chance of Earth being directly destroyed by a stellar collision is minimal, but the gravitational impact will disturb our orbit, and the Sun could shift to a completely different position within the new galaxy that forms. This might change the conditions that sustain life as we know it. And while this chaos unfolds out, here we are, living our lives, unaware that the universe is undergoing a monumental transformation, in slow motion, but inevitable. Also, this collision will generate shockwaves that will ripple through space, a kind of cosmic earthquake that could even influence the behavior of gas clouds and radiation within our own solar system. Finally, when the merger is complete, what we see in the night sky will be completely different. The Milky Way and Andromeda will no longer be separate galaxies but will become one, sometimes called Milkomeda, a new cosmic home for billions of stars, planets, and maybe future civilizations. And even though this event is billions of years away, the truth is we are already living the beginning of that story. As galaxies draw closer and begin to interact, gravitational forces unleash phenomena far beyond a simple matter collision. One of the most fascinating consequences is tidal forces, enormous pulls that stretch galaxies like cosmic jelly. These effects create impressive structures known as tidal bridges and tidal tails, long filaments of stars and gas extending hundreds of thousands of light-years into space. These tails can become nurseries for new stars and even form small clusters that, over time, may evolve into independent dwarf galaxies. Imagine a piece torn from the parent galaxy that, billions of years later, becomes a new autonomous system in the universe. Another intriguing phenomenon is the alteration of galactic magnetic fields. The close interaction rearranges magnetic lines, influencing the behavior of interstellar gas, star formation, and even the emission of radiation across different wavelengths. This can cause bursts of X-rays and other energetic emissions that reveal details of the merging process we wouldn't otherwise detect. Meanwhile, planetary systems within these galaxies are not immune to the turbulence. Planet orbits can be disrupted by close encounters with neighboring stars or by changes in the galactic environment, severely altering the conditions necessary for life. In some cases, entire solar systems may be ejected into intergalactic space, wandering alone through the void. This ejection of solar systems into interstellar space creates a little understood phenomenon: rogue planets, worlds that orbit no star, floating freely through the universe. It is believed that galaxy collisions significantly increase the population of these solitary planets. From the perspective of cosmic evolution, galaxy mergers also act as growth engines for supermassive black holes. As gas is compressed and funneled toward the centers of merging galaxies, it feeds these giants, which grow rapidly and begin to influence the dynamics of the resulting galaxy, regulating star formation and shaping its final structure. This interaction can also trigger phenomena like relativistic jets, columns of particles accelerated to near light speed, launched from the galactic center in opposite directions, stretching across space for hundreds of thousands of light-years. These jets are among the most energetic sources in the known universe and still hold many mysteries for scientists. In short, galaxy collisions are events of almost infinite complexity, affecting every scale of the cosmos, from the smallest speck of cosmic dust to the largest galactic structures. It's a dance of destruction and creation, where everything we know today may disappear, making way for entirely new forms of existence. And all of this happens right before our eyes, even if only through telescopes capable of seeing the invisible, capturing signals that transform our understanding of the universe with every new discovery. When galaxies collide, the interaction also profoundly influences the cosmic background radiation and the high-energy particles permeating the universe. This collision activates fields of subatomic particles called cosmic rays, which are accelerated to incredible speeds, nearly reaching the speed of light. These energetic particles, when interacting with the interstellar medium, generate radiation, phenomena that affect the chemistry of the space between stars. Moreover, the merger creates an ideal scenario for the formation of extreme binary systems, stars orbiting so close that they exchange matter, producing intense X-ray emissions and gravitational waves. These systems serve as natural laboratories for studying physics under conditions that cannot be reproduced in Earth-based labs. Another little explored aspect is the impact of galaxy collisions on the distribution of dark matter surrounding galaxies. Although invisible, dark matter makes up most of the mass of galaxies, and its redistribution can alter how gravity acts on stars and gas, affecting the final structure of the remnant galaxy. Furthermore, these interactions can trigger temporary, highly energetic emissions called gamma-ray bursts, GRBs, which, even occurring billions of light-years away, can be detected by specialized telescopes. These bursts are the most powerful in the universe and can provide clues about galaxy evolution after the merger. Finally, when the collision happens, it can alter the polarization of light emitted by stars and gas, an effect that helps us better understand the orientation of magnetic fields and the dynamics of matter during the merger. All of this reveals that galaxy mergers are much more than a visual collision of stars. They are a fundamental transformation in the fabric of space-time, redefining the behavior of particles, fields, and fundamental forces governing the cosmos. Beyond the visible physical and energetic effects, galaxy collisions also have a profound impact on the chemical evolution of elements present in the universe. During the encounter, there is an intense mixing of gases from both galaxies, which can drastically alter the chemical composition of the affected regions. This mixing creates unique environments where heavy elements, formed in previous generations of stars, redistribute and interact with primordial gas. This chemical mixing process can influence the creation of complex molecules, including those that are the basic building blocks for the formation of life. Combining elements like carbon, oxygen, nitrogen, and hydrogen, these environments can be cosmic incubators for even more elaborate organic compounds, suggesting that galaxy collisions could ultimately foster the necessary conditions for life to emerge in unexpected places. Additionally, the turbulence generated by the collision causes shockwaves to sweep through molecular clouds, accelerating chemical reactions and increasing the density of these regions. This density increase can lead to the formation of new stars with atmospheres rich in heavy elements, modifying the stellar life cycle of the involved galaxies. Another little explored aspect is the effect of the collision on forming planetary systems. The extreme gravitational forces can cause changes in the orientation and stability of protoplanetary disks, the nurseries where planets are born, affecting the diversity and architecture of future planetary systems. Finally, collisions can also affect the trajectories of comets and asteroids within galaxies, sending these bodies into regions where they might collide with young stars or forming planets, adding more chaos and complexity to an already highly dynamic process. All this chemical and dynamic complexity reinforces the idea that galaxy collisions are not just destructive events, but powerful engines of cosmic diversity, essential for the continuous evolution of the universe. Beyond the impacts we've already discussed, collisions between galaxies also directly affect the magnetic fields permeating the universe. Each galaxy carries a complex system of magnetic field lines, regulating everything from star formation to the propagation of energetic particles. When two galaxies collide, these fields intertwine, generating massive magnetic turbulence. These turbulences can create regions where magnetic energy converts into other forms, such as radio waves and emissions across various bands of the electromagnetic spectrum. This not only changes how we observe galaxies at different wavelengths, but can also influence the dynamics of cosmic gas and dust, shaping the evolution of internal structures. Moreover, magnetic interaction can trigger a phenomenon called magnetic reconnection, where previously separate field lines rapidly reconnect, releasing enormous amounts of energy in short bursts, similar to solar flares, but on a galactic scale. Another curious effect is that changes in magnetic fields can influence the propagation of cosmic rays, altering how they travel through space and eventually reach distant regions, including our own solar system. These magnetic processes are essential for understanding not only what happens during the collision, but also how the galactic environment reorganizes and evolves after the impact. Galaxy collisions are just part of what happens in the universe. The Milky Way is going to crash into Andromeda, and it's going to change everything here. Stars, planetary systems, even what's between them. There's no way around it. It's the next chapter for our galaxy. If you enjoyed this space journey and want to learn more about the secrets of the universe, hit that like button, subscribe to the channel, and turn on notifications so you don't miss anything from Nebulaverse.